Those who aren't with us right now can see that. Decimals. All right. Here we go. So problem number 12, where there could be confusion on it, is not understanding what ln really means. Ln is a, if you haven't seen it often, so what this is what ln means. You guys have, you remember you might have seen something like log base 2 of x is equal to 3. Remember seeing something like that? Maybe in algebra 2. And then you also learned, like, say, e to the 4th is equal to some number. Remember that? Where e is called the exponential. Well, if I do the log base e of x, that's actually what ln x is equal to. It's called the natural log. Okay? So ln is actually a mathematical working thing. And where log and natural log came into being was prior calculators, when we were dealing with extremely huge numbers or extremely huge decimals, log came into being, and then they started recognizing there was a pattern, and then doing the exponential e to the first is roughly 2.701, and it goes on forever. They were able to create these operators for math. So natural log, it's not going to be a base, because natural log is just natural log, but log base something. Basically, if I were to turn this back into an exponent, it'd be 3 to the second is equal to x. And then you could say that x is equal to 9. Okay, but that's like still algebra 2. Like, dude, who's working with that stuff? But let's take a look at problem number 12. I want to see where these intersect each other, so I'm going to go y is equal to. Now, you can, if you want, under functions on here, you can go and try and figure out where natural log is, and it looks like it's under calculus as ln. Okay, so you could do it that way, or you could just type in ln on the calculator and it's going to work. And we have so natural log of x, which is that red equation. We'll make this a little darker so it looks fancier. And then I'm going to do the other side as well. So I'm going to y is equal to negative quantity x minus 5 squared plus 4. And what we want to know is, where do these intersect? Well, the two real obvious intersections are those two x values. The 3.327 is one answer, and the 6.461 is the second answer. But the question might come, well, will this intersect? I can see that the parabola intersects there, but is it possible that as I'm going straight down, that the blue line going straight down and the red line going straight down, will they eventually cross each other? Okay, and so you could, get really, kind of goofy on it and say, are they crossing each other? And as you look down here further, you'll see that they are. So I have this intersection, I have this intersection, and I also have this intersection. So that answer actually has 3 solutions to it. Okay, and basically what's taking place, if you looked at the graphs, you have one graph that's doing this, and then you have another graph that's doing this. So you have these 3 intersections that are taking place with the graph. I mean, I know that's not really a true parabola, but that kind of can be a little tricky when you're working with the problems, especially like, what if they intersected each other at like -3 trillion? I mean, it's going to be hard to find on decimals if that really happened. I wouldn't do that to you, but there's really weird, strange math people that sit there and just fathom this kind of stuff and think it's the greatest thing in the world. So that problem actually has 3 solutions to it. Let's see if I could zoom in and get it a little better. So I have here, nope, got undefined. There we go. Come on. There's one answer. There's the other, and there's the other. So all those x values, so 0, 3.327, and 6.46 are your solutions to this problem. Does that help you out on that? Yeah, that's cuckoo math. I don't know. Anyone who mixes parabolas and natural log. Hey, so I have a question for you. Does anyone want to know where this math starts incorporating over top of itself?
I want to know.
You want to know?
Mm-hmm.
There was actually a team of female mathematicians that worked for NASA. You might have seen the movie.
I've seen the movie.
This is the math they were doing. Like, what's going to happen if we launch a rocket, it's going to do a parabolic shape. But now we know we're going into an orbit of the planet, which is circular. So we're going to intersect a circle and a parabola. How are we going to make it work? It has to come through at this exact angle. If it doesn't, we skip off. So basically, the math that's taking place is like this. X squared plus y squared, y squared equals 5. No, equals 10. No, equals 20. Something like that. So what they're basically looking at is this point right here, because you're dealing with two different types of orbits. That's exactly where the rocket, once it comes back down and free falls back to Earth, it has to come through at that exact point in that window. If it doesn't, the atmosphere, the object would come down and brush alongside of it and then bounce back out in outer space. And it was relying on gravity to take it down, but because it came down and it brushed off the atmosphere and it pushed it out to outer space, those astronauts are going bye-bye, and we're not going to see them again. So that's the math right there that they were doing, is realizing, okay, if I were to take a circle and a parabola, and I'm realizing I have a rotation. Now there's a few other things that take place, because the red circle is orbiting, it's moving, the rocket's moving, and so you had to take all of the motion things into account. Basically, when a space capsule re-enters the atmosphere, it has about a 3-inch margin of error that it can make. It's either, if it comes through at the wrong angle, it comes through hot, and the plates of the heat plates on the bottom of the spacecraft can't handle it because it gets too hot, so you would burn up. Comes right through perfectly, though you create a large amount of heat because of the friction of coming through the different spheres of the Earth. It'll come through, but it's enough heat. But they had to realize the amount of heat that was coming through as the rocket was coming back through could happen. And if you didn't do it right, it would bounce right off the atmosphere, because the atmosphere acts like kind of a bubble, a safety bubble. So there you go. Now you know.
I didn't know that was based on a true story.
It is a very true story. Very true story. And I'll tell you what, the math that goes along with any type of space exploration, it's crazy. And you don't want to rely on a computer, because when you rely on a computer, the computer does exactly what you say. And I don't know if you are aware of this, but we sent a probe to Mars that they lost. And then when they look back at the program, the rocket did everything it was told to do. But the calculations were done in miles per hour, not kilometers per hour. Someone going to lose their job. Units are important. So this is basically, here's your rocket ship math, which is cool. All right, and then you said number 13 as well? Oh, cool. Look, number 14 talks about a missile. All right, man, we're doing all kinds of rocket stuff today. All right. So next problem. We have an equation that goes through a particular point. So I'm going to create a table here. And we're going to plug in -2 and -1. So that finds us our point. And then we want to know what goes through this point, and it is parallel to this. Okay, so this is just a line. So 7 minus 3x. Okay, So the blue line obviously is not going through the black line. So what we want to do is we want to find the linear equation that is going to go right through that black dot and is parallel to the blue line. So what do you know about parallel slopes, friends? Lines that are parallel, what's significant about their slopes?
Same slope.
Same slope. So what I can do is I'm going to come down here and I go y sub 1 tilde, okay? What is the slope of my blue line? It's out of order, so be careful. -3. So I have -3x, okay? And then I'm going to go plus b. And oops, 3. It should have been x sub 1. Sorry, x sub 1 plus b. So the line y equals -3x minus 7 is the line parallel. So if I go down here and said, okay, yeah, I'm not sure if Sturb knows what he's talking about, which is very possible. If I go, so the purple line is what we're going to do. So we're going to go minus 7. Ready? Purple line should go right on top of the green. Boom. It's there. Okay. That's pretty cool. And then we have number 14. Oh, yeah. All right. Desmos is still our best buddy and pal here. All right. It says let h at t. H at t is just a height equation. H at t is the same thing as y. It's just functional notation. Is equal to -16t squared plus 480t plus 22. Represents the height of a missile in meters after t seconds. Use the eval or value to find the height of the missile after. Okay. Okay. So let's just graph what this looks like, and this should give us some thought. -16, and I'm going to change t to x, make it x squared plus 480x plus 22. And I could probably zoom out on this a little bit and get a little bit better picture of this. Okay, so I'm going to spread and down. There's the top of my parabola. Let's see, can I keep this down? Yeah. All right, so this is our parabola, and I'm just zooming in. So we want to know after 1 second, 10 seconds, 25 seconds, and when does it hit the ground? Well, let's figure out where it hits the ground right now. Well, I'm way up in the y direction of 3,620. So if I wanted to find the vertex, I know at 15 seconds into flight, my rocket is 3,622 meters above the ground. Okay, so that's pretty high up there. Okay, 3,622 meters, but it doesn't want 15 seconds, but it's curious about 10 seconds. All right, so what we're going to do is a couple of things. Okay, if I type in x equals 1, and I take us back to home, after 1 second, where's my parabola? It's black. After 1 second, all right, the black's starting to come in. I'm looking for where the red and the black intersect. They appear to be parallel right now, but the black is a parabola, so it's getting closer and closer to the red staying at a constant distance at 1 second. Getting closer. Oh, this is going to be awesome. It's going to cross. They look like they're touching each other. Is it hitting yet? So at 1 second, our rocket is 486 meters up from where it launched from. Okay? So if I want to find 10 seconds, I'm just going to make this 10. So notice where the red line went. So now I got to just zoom out a lot more. I know at 15 seconds it was at its max. Nope, still not there. Touch it. There we go. Ooh, touch. So at 10 seconds into our flight, our rocket is now at 3,222 meters above the ground. And then at 25 seconds, so at 15 seconds, I'm at my max. So what do we know at 25 seconds? Is it lower or higher than our max? Lower, because it's come back down. Okay, so then I need to zoom in out at this. So at 25 seconds, we are coming back to the ground. We are 2,022 meters off the ground. And when does this hit the ground? When does this hit the ground? Well, we go back to home. Scroll over this way. And after at 30.046 seconds after I launched my rocket, it now hit the ground. Okay? The nice thing about this type of math is the Desmos is going to work for you. This goes along with a lot of physics types of stuff. The negative 16 is basically a constant of some sort. The positive 22 basically means that my rocket was sitting on a platform that was 22 meters up, and then it launched from that, like top of a building or something. But then it came back down. In fact, if you go back this way and try and look at your parabola, if you click here, notice at 0, it's at negative 0.046 of a second. Okay? Because that means that we were 22 meters up before our rocket started. I bet you our y-intercept, if we go up to 22, that's where my object launched from. So at 0 seconds, I'm 22 meters off the ground because I'm on top of a platform or a building or something. And it launches straight up and down. Huh. I kind of think this is fun math. I don't know about y'all, but I'm kind of dorky that way. Okay. Other questions you might have come across on the homework? Feeling comfortable? Okay. So, So I want to give you the chance to work on this assignment. Tomorrow's real life math. What am I talking about? I told you yesterday. What did I say?
I won't be here tomorrow.
What?
She's the J. I told you, I have to watch my dogs.
Bring them here.
That's too many.
That'd be
All
awesome.
6 of them.
That'd be the best day ever. What question did I ask you to ponder the other day? Had to do with cake.
Oh yeah, how you would split a cake up to be the most even between you and someone else.
Yep, fair division. That's tomorrow. Okay. Now, it's a little bit beyond just splitting the cake. It goes beyond that, but anyone have any ideas yet on how you would split a piece of cake between you and your friend, and you want the most equal piece of cake? How do you and your friend split it so no one is getting shortcutted? What do you think?
You have one person split and the other choose.
That's it? Yep. There's two of you. The two of you want to split a piece of cake.
Mm-hmm.
First off, you have to figure out who's going to cut it.
You're cutting it.
Okay, you're going to cut it, but
I'm
she gets to
tasting.
pick which piece she gets.
That's fun. As long as she picks the bad piece.
Mm.
No.
Yeah, but you're like, okay, this is going to be the most even cut I can make because there ain't no way someone gets more frosting than me. Right?
That's fine. You can have the frosting. I like,
I like-
the cake.
I
Oh.
love the cake.
Oh,
I don't like a lot of frosting.
I like frosting, especially because I can feel my blood sugars spike. You ever want to see me freaky? Bring me in a tub of frosting, I'll eat it right in front of class, and I'll be like over there trembling in the corners, like stir right, just let them be. Oh man, I'm not diabetic. I'm not hypo or hyperglycemic. I can just tuned with what my body does. All right, so this assignment, graphing review. I will give you, and the reason I say that twice is because that's what it's titled. It's a front and a back, and this will be due Monday. And I'm going to come around, double check homework, make sure you're good, and put in last night's homework as well. Sound like a plan?
Mm-hmm.
This